Hi everyone, welcome to my channel. Today's topic is Werner's theory of coordinate compounds. According to Werner's theory, the coordinate compound metal ion can exhibit two types of the valencies. One is called primary valency, next one is secondary valency. So generally the primary valency corresponds to the oxidation state of the metal ion and the secondary valency corresponds to the coordination number of the metal ion. For example, let us come to CONH3 taken 6Cl3. So in this coordinate compound, the central metal ion is the cobalt and the ligands are ammonia, and generally primary valency is satisfied with negative charged ligands and secondary valency is satisfied with neutral or negative charged ligands. For example, in this example, the primary valency is satisfied with 3 Cl minus ions and the secondary valency is satisfied with 6 ammonia molecules. The 3 Cl minus ions are satisfying the primary valency, 6 ammonia molecules are satisfying the secondary valency. And when you come to how to write a structure according to Werner's theory, generally are using this type of the mechanism, that means inner pair. When you come to the inner pair, it is the coordination pair. So which are bonded with secondary valency will write in the inner pair. And when you come to outer pair, that is the ionization pair, and what it may be attached to the primary valency, that will be right in the outer pair. So come to same example, CONH3 taken 6Cl3. The 6 ammonia molecules are inner pair and 3 Cl minus ions are outer pair. That means here you are writing the 1, 2, 3, 4, 5, 6. These 6 ammonia molecules are writing as an inner pair. So these are the unionized molecules and 3 Cl minus ions are written in the outer pair. These are the ionized molecules. That means when you are going to write the Werner's structure of the coordinate compound, you are writing the secondary valency with using the normal line and primary valency by using the dotted line. Now all the primary valency will be shown by using the dotted line and secondary valency will be used by the normal line. So like that you are writing the structure of the coordinate compound according to Werner theory. Okay, let us come to example how to write a coordinate compound structure according to Werner theory. Come to the example CONH3 taken 6Cl3. Secondary valency will be written as normal line. Primary valency will be written by using the dotted line. So in this example, 6 ammonia molecules are attached to the central metal by using the secondary valency and 3 Cl minus ions are attached to central metal by using the primary valency. All the secondary valency, that is ligands, are written by using the normal line and primary valency will be written by using the dotted line. And according to the number of ligands, the geometry of the compound will be there. So in this compound, total number of ligands are 6. That's why this compound present in the octahedral shape. So octahedral is nothing but here total 4 ammonia molecules are present on the plane. This total 4. And one ammonia molecule is present above, another ammonia molecule is present below. That means the compound structure is octahedral shape. Let us come to one more example. CONH3 taken 5ClCl2. The coordination number of the compound is 6. The CONH3 taken 5ClCl2 coordination number is 6. In this molecule, 5 ammonia molecules and 1 chlorine. 5 ammonia and 1 chlorine is attached to the secondary valency. So 1, 2, 3, 4. These 4 are present on the plane and 1 ammonia is below and 1 chlorine is above. And when you come to this chlorine, it is bonding with the central metal ion by using the secondary valency and also it is satisfying the oxidation state, because due to the negative charge it is satisfying the oxidation state That's why this Cl minus ion is attacking the, that is attached to the central metal ion with a secondary valency and primary valency. So in the some molecules, some negative ions will satisfy primary valency as well as secondary valency. If any ion is satisfying primary and secondary valency, that will be written by using the thick line and dotted line. So because it is satisfying the two valencies, you have to write that is thick line and dotted line. This Cl is satisfying the primary valency as well as secondary valency, and remaining two chlorines only satisfying primary valency. That's why I am writing that as a normal dotted line. So this is the structure of the CONH3 taken by Cl2. So that means when you are coming to the structure of the any coordinate compound, the secondary valency will be written by using the normal line, primary valency will be written by using the dotted line. If any ion is satisfying primary valency as well as secondary valency, we can write that as normal line and dotted line. So this is the structure of the compounds. And when you come to the geometry of the compound, generally the geometry of the compound will be depends upon the number of secondary valencies. So depends upon the secondary valency, the geometry will be there. If the secondary valency is 6, that is nothing but coordination number, the structure of the compound is octahedral. If the coordination number is 4, that may be tetrahedral or square planar. If the coordination number is 3, that may be pyramidal or trigonal planar. Or if the coordination number is 2, the structure may be linear in structure. Like that, depends upon the secondary valency, the structure of the compound will be there. And one more thing, according to the Werner theory, we can assume the number of ions produced by the any coordinate compound. So generally when you come to the any coordination pair, so what it may be, inner pair, the central metal ion and inner pair, that is the only one ion, and remaining outer space will be released as a ion. That you have to remember to count the number of ions produced by the coordinate compound. That means the inner pair and metal will be only one unique ion, and the remaining will be, that is the outer pair ions only, that will be released as a ion. For example, in the CONH3 taken 6Cl3. In this example, the CO and NH3 taken 6. This total is a 1 ion because NH3, 6 ammonia molecules are attached to cobalt in the inner shell. That is the secondary valency. That's why this total will be comes as a 1 ion, like that. CONH3 taken 6 plus 3, and these 3 Cl minus ions will be comes outside. 3 Cl minus. That means CONH3 taken 6 Cl3 will produce the total 4 number of ions. Similarly, let us come to CONH3 taken 5 Cl2. In this, 5 ammonia molecules and 1 chlorine is attached to central metal ion by using the secondary valency. That's why this total is 1 unique ion, and the remaining 2 chlorines will be comes into as a 2 ions. That means CONH3 taken 5 Cl2 plus and 2 Cl minus. It will produce the total 3 number of ions. Let us come to one more example. CONH3 taken 4 Cl2 Cl. 2 Cl and 4 ammonia molecules are attached to central metal by using the secondary valency. That's why it will come as a unique ion. CONH3 taken 4 Cl2. It is a one unique ion, and next we will get this chlorine as a 1 ion. So it is producing the 1 chlorine and 1 complex ion. Like that you are getting the total 2 ions. And when you come to CONH3 taken 3 Cl3. In this, 3 Cl and 3 ammonia are attached to the central metal with a secondary valency. That's why it can't produce any ions. It is a stable one, and that's why it can't ionize in the solutions, and it can't produce any number of ions. Next, let us come to limitations of the Werner's theory. So this theory is having the so many number of the limitations. Generally, it is not explaining the what is the nature of the bonding. So nature of the bonding is nothing but how the central metal ion is bonding with the ligands, or how the central metal ion is bonding with the outer shell ions. So that means it is not explaining the what is the nature of the bonding, and also it is not explaining the geometry of the compound. So structure of the compound, how it is forming, octahedral, tetrahedral, square planar, how the structure is obtaining. It is not used, is that a ionic bond or covalent bond or coordinate covalent bond. And this theory is not explain the magnetic properties and color of the compound. And this theory is not used any electronic configuration in the writing of the structure. Without using the electronic configuration, this theory is explaining the bonding of the what is that one central metal ion with ligands and central metal ion with outer shell ions. So these are the some of the limitations of the Werner theory. It is not explaining the nature of the bonding, it is not explaining the geometry of the compound, it is not explaining the magnetic behavior and color of the compound, it is not used the electronic configuration to explain the bonding. Thank you.